Hello dear students, myself Dr. Kapil Bohra, and today in this video I am going to talk about various types of stereoisomers, their definitions and examples. I will use a flow diagram to explain stepwise different types of isomerism exhibited by various organic compounds. We will consider two compounds A and B, and we will evaluate the relationship between these two compounds at every stage in the flow diagram. To check the isomerism in any pair of compound, first of all, we check the molecular formula. So first question we always check, are two compounds A and B have the same molecular formula? If molecular formula is same, we call them isomers. If molecular formula is different, there is no isomerism possible. After checking this first point, we check another point, that is, are the structure of compound A and B completely superimposable? If two compounds are having same molecular formula and their structures are completely superimposable, it means these two compounds are identical structures possible. Then we check for the third point, are the structures of A and B have different order of atom connectivity? At this point, we call them isomers. What are isomers? Two compounds having the same molecular formula and non-completely superimposable, we call them isomers. In isomers, then we check the order of atom connectivity. If two compounds are having same order of atom connectivity, we call them stereoisomers. If two compounds having different order of atom connectivity, we call them constitutional isomers. Let me give you an example. CH3, CH2, OH and CH3O, CH3, ethanol and dimethyl ether. If we consider this is compound A and this is compound B, molecular formula of both the compound is C2H6O. C2H6O. Now we can see that molecular formula of both the compound A and B is same. So our point number 1 is fulfilling. Second point, are these two compounds, structure of these two compounds non-superimposable? Yes, so our second point is also fulfilling. So these two compounds are non-superimposable. Now the third point, are these two compounds having different order of atom connectivity? So yes, these two compounds having different order of atom connectivity. As we can see here, this compound is having carbon, carbon and oxygen. So this is the atom connectivity. In this compound, in dimethyl ether, we can see COC. So as we can see, the order of atom connectivity is different in these two compounds. So these two are constitutional isomers. In this case, because the functional group are different, this is alcohol and this is ether, so we also call them functional group isomer. Functional group isomer. So we can say functional group isomers is a subtype of constitutional isomers. Similarly, if we talk about position isomer, for example, if I take orthonitrophenol and paranitrophenol. In orthonitrophenol, there is a sequence order of atom connectivity two carbons between oxygen and nitrogen, but in this case there are four carbon between oxygen and nitrogen. So order of atom connectivity is again different, and these are called position isomers because position of nitro group is different. So these are position isomers, but this is again subtype of constitutional isomers. So these are the example of constitutional isomers. Similarly, if we talk about 2-butene and 1-butene, that is also position isomers, but order of atom connectivity is again different in that also. So these all are the example of constitutional isomers. So all those compounds, all those isomers which having different order of atom connectivity, we call them constitutional isomers, and all those isomers which having the same atom connectivity but different orientation in space, we call them stereoisomers. So what will be the definition of stereoisomers then? Stereoisomers, two compounds having the same molecular formula, non-superimposable, same order of atom connectivity, but different orientation in space. So that is called stereoisomers. So two compounds having the same molecular formula, non-superimposable, same atom connectivity but different orientation in space are called stereoisomers. Now after knowing that these two compounds are stereoisomers, we have to go further. We will check the next question. Are the structures A and B identical after rotation around carbon-carbon bond? We will try to rotate our molecule, our stereoisomers. If we able to convert A into B just by doing rotation, if we can convert A into B, these are called conformational isomers. These are called conformational isomers. If I take this is a staggered form, and if I rotate, this is a staggered form of ethane, and if I rotate the hydrogen of back carbon, we will get this. So these are staggered and eclipse form. This is staggered and this is eclipsed. So we can convert this structure A into B just by doing rotation around carbon-carbon bond. So these type of stereoisomers are called conformational isomers. So what is the definition of conformational isomers? Those stereoisomers which can be interconvertible through rotation around carbon-carbon bond are called conformational isomers. Then there is another type of stereoisomers. They are called configurational isomers, sorry. So what are configurational isomers? Two molecules having the same molecular formula, non-superimposable, same order of atom connectivity, and non-interconvertible after rotation around carbon-carbon bond are called configurational isomers. Or simply we can say those stereoisomers which cannot be converted into one another just by rotation around carbon-carbon bond are called configurational isomers. After knowing that these two compounds are configurational isomers, we can further go on and we will check that whether these two compounds are mirror images, non-superimposable mirror images of each other. So if two compounds A and B are mirror images of each other, and they are non-superimposable, like if I try to overlap this B with A, then it's not possible. If it's not possible, then it means they are non-superimposable mirror images of each other. These are called enantiomers. So now we can define enantiomers. So what are enantiomers? Those stereoisomers which cannot be interconvertible just after rotation around carbon-carbon bond, and which are related as non-superimposable mirror images. So stereoisomers which are not identical after rotation around carbon-carbon bond, not identical, and related as non-superimposable mirror images are called enantiomers. Next point. Diastereomers. So what are diastereomers? Stereoisomers which are not interconvertible just after rotation around carbon-carbon bond and related as, and they are not mirror images of each other. Because I have written no here, it means that A and B are not mirror images of each other. So if those configurational isomers which are mirror images of each other are called enantiomers, and those configurational isomers which are not mirror image of each other are called diastereomers. So diastereomers A and B are stereoisomers, but they are not mirror image. Of each other. These are called diastereomers. Then further, last point we can check. Are the structure of A and B having double bond or restricted rotation? So those diastereomers which are having double bond or restricted rotation are called geometrical isomers. Like cis and trans. Cis and trans, if we check cis and trans, it's very interesting. If we check cis, for example, cis and trans, this is trans isomer. So first of all, we have to check whether it is stereoisomer or not. Let's start from the question number 1. Cis and trans having the same molecular formula? Yes, cis and trans have the same molecular formula. Are they completely superimposable? Cis and trans are not superimposable. Then cis and trans are having same order of atom connectivity. Yes, they having the same order of atom connectivity. It means they are stereoisomers. So it means cis and trans are stereoisomers. Then can we convert cis into trans just by doing rotation around carbon-carbon bond? No, we cannot convert cis into trans just by doing rotation around carbon-carbon bond because of restriction in rotation because of double bond. So it means they are configurational isomers. So cis and trans are configurational isomers. Then again we will check whether cis and trans are mirror images of each other. No, cis and trans are not mirror images of each other. It means they are diastereomers. So those diastereomers which have double bond or restricted rotation are called geometrical isomers. I have not covered optical isomerism and geometrical isomerism in this video. I will make a separate video for that. That stereoisomers can be of two types: geometrical isomers and optical isomers. That depends on the optical activity of the isomers. So I will cover that topic in a separate video. So right now I have covered all these isomerism. So now in this after reading this flow diagram, we are able to differentiate between constitutional stereoisomers, conformational isomers, configurational isomers, enantiomers, diastereomers, and geometrical isomers. So we have learned about the 7 different types of isomers, their relationship between these, and difference between these terms. So once again I want to repeat the definition. Only definition I'm going to repeat. If someone asks us that what is the definition of constitutional isomers, so simply we can make definition from this flow diagram. So constitutional isomers. What are constitutional isomers? So two compounds having the same molecular formula, non-superimposable, and having different order of atom connectivity are called constitutional isomers. What are stereoisomers? Two compounds having same molecular formula, not superimposable, same order of atom connectivity, but different orientation in space are called stereoisomers. Third, what are conformational isomers? Two compounds having same molecular formula, non-superimposable, same order of atom connectivity, and identical after rotation around carbon-carbon bond are called conformational isomers. Example, staggered and eclipsed. Then configurational isomers. Again, two compounds having same molecular formula, non-superimposable, same order of atom connectivity, and not identical after rotation around carbon-carbon bond are called configurational isomers. Then enantiomers. Those stereoisomers which are not identical after rotation around carbon-carbon bond and rated as mirror images of each other are called enantiomers. And those stereoisomers which are not identical after rotation around carbon-carbon bond and not related as mirror image are called diastereomers. And those diastereomers which are having double bond or restricted rotation are called geometrical isomers. I have already discussed this A and B. These two compounds having the same molecular formula, isomerism is possible. Second point, identical structure. Yes, these two compounds are completely identical. If I overlap these two compounds, they are completely superimposable. So identical structures. Third point, This point I have already discussed, these two compounds having the different atom connectivity, so they are constitutional isomers. Fourth point, I can convert this A into B just by doing rotation. In this case, I can rotate this OH. This OH can be rotated. This OH can be rotated. So we can convert A into B and B into A. So these structures are interconvertible after rotation around carbon-carbon single bond. So they are called conformational isomers. So what are stereoisomers? Stereoisomers, I have already discussed, two compounds having same molecular formula, non-superimposable and having same atom connectivity but different orientation in space. Stereoisomers are of two types, configurational isomers and conformational isomers. Configurational isomers, those stereoisomers which are non-interconvertible after rotation around carbon-carbon bond. And conformational isomers, stereoisomers which are interconvertible after rotation around carbon-carbon bond. Then configurational isomers are of further two types, enantiomers and diastereomers. So a pair of stereoisomer which are non-interconvertible after rotation around carbon-carbon single bond and non-superimposable mirror image of each other are called enantiomers. A pair of stereoisomers which are non-interconvertible after rotation around carbon-carbon bond and non-mirror images of each other are called diastereomers. And a pair of stereoisomer which are non-interconvertible due to presence of double bond or restriction in rotation around carbon-carbon bond are called geometrical isomers. Now we can see the example like conformational isomers, eclipse, staggered. We can convert eclipse into staggered, staggered into eclipse just by doing rotation around carbon-carbon bond. So this is the definition of conformational isomers. So we can convert chair into boat, boat into chair. This is also an example of conformational isomer. Another is enantiomers, D erythros and L erythros. We can see these two are the mirror images of each other. So these two are stereoisomers, configurational isomers, and those configurational isomers which are mirror images of each other are called enantiomers. In this case, we can see these two are not mirror image of each other, but these two are configurational isomers as well as stereoisomers. So these are called diastereomers. Those configurational isomers which are not mirror image of each other are called diastereomers. And these cis and trans I have already discussed. Cis and trans, these cis and trans are diastereomers but having double bond. So there is no rotation is possible in this case, and because of restriction in rotation, this diasomerism is these diastereomers are possible. That is called geometrical isomers.